All right. Hello, everyone. I'm very excited to be here, and thank you for joining us today on this exciting webinar on AI-powered agriculture. I'm Guy Sela. Many of you already know me. Either you have my book or from my ventures. I'm an AgTech entrepreneur, established several ventures, AgTech companies, startups, and among them Cropea and the Yields app. I'm joined here today by my colleague Joshua Ellis, who's here with me, and we're actually thrilled to take you on a journey into the world of artificial intelligence and how it's transforming the way we farm. So today we'll see how AI, artificial intelligence, brings innovative technologies to the field, empowering farmers and companies to tackle challenges and embrace sustainable practices. The webinar is recorded, so you'll be able to get a recording of this webinar. And also, if you have any questions, feel free to use the chat or the Q&A section, and we'll answer all your questions by the end of this webinar. Okay, so let's start. So in today's dynamic world, and we know that everything is very dynamic, the agricultural industry in particular faces an array of challenges that demand forward-thinking solutions. Challenges like climate change, soil degradation, water scarcity, pests and diseases, they all pose challenges that farmers confront daily. And now farmers have to actually make hundreds of complex decisions under ever-changing environmental conditions. And over the past decade, okay, I wouldn't say that AI in the past decade, but in the last recent years, but it evolved over the past decade. So AI emerged as a groundbreaking technology that has an immense promise for revolutionizing agriculture, and it brings new approach of data-driven decision-making and precision farming. And today we'll see the applications of AI in agriculture, and by the end of the webinar, we'll also see a live demonstration of an AI platform. So actually, why now? Why? How come that the AI just bursted into our lives and became like, a few years ago we didn't hear about AI, for sure not in agriculture. And I can tell you that, I remember 25 years ago when I was agronomist in greenhouses. Okay, for instance, we went and took records of temperatures, manual records of temperature in the greenhouse, minimum, maximum temperatures, took photos if we took photos, and using films that had to be sent to the lab for development, etc. Then a little bit after, things became more digital. Okay, we had more digital devices, Excel sheets, etc. But also those digital devices were connected with cables. We had to dig in the ground and to draw cables in order to get the information from the field to the computer, to the office, right? So because internet was not available, and then came the internet of things, and actually this is how AI became possible, right? From manual records to digital records of data that comes. Data is the key word here. To internet connectivity that allowed big data to be created. Big data is large amounts of data sets, okay? Because AI, as we'll see, requires a lot of data, and this enabled the development of artificial intelligence in general, and particularly in agriculture. So today we actually have hundreds of different devices and technologies that can collect data from the field and even from above the field. I can tell you that I can now, for instance, access almost any agricultural field in the world and see when it was planted, what's the status of the crop, and more. Okay, and I can do that instantly. So today we have sensors, soil sensors, plant sensors, drones, of course, that collect data from above the field, where there are different cameras that are mounted on the drones, satellite imagery, different bands that we can analyze. That's on the data collection side. On the other hand, there is the precision application, or the equipment that machinery that applies different, for instance, fertilizers, water, pesticides, seeds, etc. Right? So there is equipment that allows precise application of inputs, and in between there's the decision making, where I think AI goes also there very strongly, as we'll see. Now, AI, when we're talking about AI, artificial intelligence, it's not one technology. So there are different domains of AI, and this includes machine learning. Machine learning involves training algorithms to learn from big data, from all this data that is collected, that is now available. Right, the data now on the cloud is readily available, and make, based on this data, predictions or decisions. Another aspect or domain of AI is computer vision, and this involves teaching computers to interpret and understand visual information, image recognition. For instance, we take a photo, we'll see some examples. Okay. NLP is another aspect, which is natural language processing, okay, which enables us, or is capable of interpreting human language. Okay, when we speak, even I think in PowerPoint, you can have this option of having subtitles, automatic subtitles, for instance. Robotics and automation. So robotics and automation are with us for a long time already, and I'll discuss a little bit about precision agriculture, where we have robotics, we have automation, we have machinery that can apply inputs in a very precise manner. Okay, but when we put AI into this, we enhance their capabilities, and they actually learn and become autonomous. So they can become autonomous and perform different tasks. And there is also predictive analytics that actually uses historical data to make predictions about future events or trends. Okay, very important, for instance, in the yield prediction, weather forecasts, etc. Now I'm going to go just a little bit technical, just to go a little bit into the world of AI and what it means, not to keep it like just a general word. So I'm going to try to explain in a simple way one subset of AI, and actually this is a subset of a machine learning, and that's the neural networks. You probably heard this term, so I will just briefly try to explain about this subset of AI and how it works. Now, neural networks are really exciting because they are designed to work somehow like the human brain. Okay, the neural network consists of small units, okay, that are called neurons, and each neuron is in fact a mathematical function. Now we have input data, okay, that flows through layers of neurons. Now the input data is the data that describes the problem, all right, different parameters that we think that affect the problem that we want to solve. Now here, each neuron performs a calculation based on the input it gets, but it also has what's called connection weights and biases. So connection weights is basically how much influence each input has on the output of the neuron. And the bias acts basically as an offset that allows the neuron to adjust its output independently of the input data. I know, very technical, I try to make it simple, but basically this is a very smart way of processing data. Now, the interesting thing is that initially the neural network produces a prediction for a given input of data based on initial weights and biases. And later on, the outputs are compared to actual ground truth outputs of the training data. It must have training data. For instance, okay, if we want to, and this is used, for instance, in the image recognition, right? As you add more images, okay, the network learns and improves itself to better identify what it sees in the image. Now, during the training phase, there is always a training phase in AI, in neural networks. The network aims to minimize those prediction errors, right? And not only that, but also the weights and the connection weights and the biases are continuously updated throughout the multiple iterations as we feed more training data into the network. This is just an attempt to explain how this works. It's actually like a thinking machine, and let's try to understand it even better. So before we delve into applications of AI in agriculture, let's just try to understand a little bit more about the differences between conventional algorithms and what we see and AI, some key distinctions. For instance, in terms of data-driven learning, conventional algorithms use fixed rules. They can deal with fixed rules. For instance, I don't know, the area of a rectangle. Okay, so multiply the width by the length. All right, simple. In AI, it can use large data sets to automatically identify patterns and trends. Neural networks is one example of that. Adaptability. Adaptability in the conventional algorithms and conventional programs, you are static and inflexible. They have their algorithm, and it's one algorithm. If you have the same input, you get the same output. It's not the same in AI. With AI, it adapts and improves its performance over time. In terms of decision making, one of the most important things here. Here in conventional algorithms, we have predefined logical steps, whereas in AI, it's based on probabilities and statistical inferences, right? So there's also always those weights, the weight is the importance of each, in case of neural network, that each neuron gives to the data that it receives, etc. So in terms of problem solving capabilities or problem complexity, conventional algorithms are suitable for well-defined rule-based programs. We have a rule we can solve, we have an equation or a simple algorithm, and this is how it works, but AI can work with unstructured problems. By the way, for instance, just to explain that, we've talked about voice recognition, or NLP, right? Each one of us has a different tone of voice, speaks differently, different accents. It's not that you can put it in an algorithm, in a simple algorithm, and it will be able to interpret that. So this requires AI capabilities. And the last is human intervention. While conventional algorithms require humans to analyze the problems, to define the rules, write the code, adjust the code, write it again. In AI, it's a bit different because it can learn and improve independently. It still needs feedback, still needs human feedback, because humans eventually we tag, it needs the end result. So in AI, again, I'll take the example of image recognition, because it's a simple example, right? If you want to identify a certain disease and we took a picture, and then the AI throws out a certain result, right? So there's a human that says, all right, this result is correct or not. This is called the training, okay? Then if it's incorrect, it goes again through the training process, tries to find different connections, for instance. And of course, as we add more data, it improves itself. All right, so now we get to AI in agriculture and the applications of this technology in agriculture. Now, there are many applications. Of course, we'll not go through all of them. We'll just give some examples. Over here, I have some examples. The future, of course, is very exciting and very promising, and there are really crazy things that can be done. And just imagine if in just 20 years we reach from taking manual records to AI technologies, that what we can achieve in the not very far future. So today, some of the applications of AI are, for instance, AI-powered precision farming, crop monitoring, pest and disease prediction. Those are the main ones. Weather and climate predictions, autonomous vehicles and robotics that do different tasks, as I mentioned, AI-based decision making, and AI applications, for instance, for yield forecasting and traceability, in case large companies, they want to trace the supply chain, okay, all the processes throughout the supply chain, etc. It's all, and we have current AI technologies that deal with those things, and it's all just begin. So let's just dive in a little bit and talk about some of those technologies. So precision farming, AI-powered precision farming. Now, as I mentioned, precision farming is a technology that really was, actually, it's one of the, I wouldn't say the only, but it's a technology that was being adopted, all right? So it's very popular, for sure, in North America, in the broadacre crops. And basically, precision farming itself refers to application of variable rates of inputs to different zones of the field, okay? Because it can apply different rates for different conditions, different zones of soil, different types of soils, for instance, different yield forecasts, etc. Right? So this already exists. Now, where does AI come into play here? Today, we collect a lot of information, a lot of data from various sources like soil sensors, weather stations, satellite imagery, historical records, and there is more and more drones, etc. Now, the AI can actually create the zones automatically using all this data, all this complex data, creates the zones in the field. Zones are different parts of the field with different properties because the field is not uniform, right? If we have a large field, for instance, we usually don't want to apply the same fertilizer rate for the entire field, although this is still the main practice, or we don't want to have the same sowing density, or give the same irrigation rate, etc. So AI can create those zones automatically, and based on those zones, to automatically create the prescriptions, okay? The prescriptions for fertilizers, for pesticides, for seeds, for variable irrigation, etc., for spraying, etc. So, and the nice thing is that it can learn. It can first account for unforeseen factors like weather conditions. Weather conditions change. It's not the same prescription that we created at the beginning of the season, okay? This might be different. There might be changes in the yield forecast, might be changes in weather conditions that will affect the crop or the development of the crop, etc. So the real-time learning and adaptation is very important here. And of course, that it also learns from season to season, all right? So it's not just in-season adaptations, but also in between, between seasons, all right? So it learns and creates history. And of course, you can understand that as much as we have more data, more information, okay, those systems can learn more and more. So we started with precision agriculture that enabled applying precise rates for different zones of the field, but someone had to input the rates, to input the zones, okay? But now they can be created by AI. So this is a very promising thing in AI. Here we see examples, okay, we take pivots, for instance. So today there are pivots that can apply variable rate irrigation. The sprinklers can be automatically adjusted to apply precise rates of water for each zone of the field, etc. This is like a map, zone map of a field. I don't know what this is based on, but could be soil, could be could be yield, etc. Yield potential. The tractors, of course, have GPS systems and can go and apply the inputs very precisely and learn, of course, from the information. By the way, even more interesting, today we also install sensors on, for instance, on the pivot. So there are technologies that actually take data from the field during the irrigation. So basically, you have a continuous flow of data. So imagine you have data from here, from drones, from the satellites, from so much data. The question is, what do we do with the data? I mean, if 5-7 years ago, the problem was data. The problem was data. We maybe we can solve problems, but we don't have enough data, right? Today, data is becoming less and less of a problem, and it's becoming more and more available and accessible. Like I told you at the beginning, I can now, at this moment, access almost literally every agricultural field in the world, and got a lot of information about this field for free. Okay. All right. Next application is crop monitoring. All right. So crop monitoring basically refers to analyzing or processing data from, let's say, satellites, drones, weather stations, and even sensors, okay, in real time, and provide real-time insights into the current status of the crop. And what do I mean? For instance, growth stage. What growth stage is the crop? Usually what we do, we know, all right, it's if we talk about any crop, I don't want to give any specific example, but the duration of the vegetative stage is 14 days, all right? Maybe it's not, maybe conditions have changed, maybe now we have different weather conditions and the crop is responding differently, okay, reacting differently here. So monitoring, knowing the growth stage of the plant, of the crop is very important. Important for fertilizer applications, important for predicting pests and diseases that might attack the crop, important regarding even the harvest. When do we have to harvest? When it's ready to harvest, and even to be able to forecast the harvest time. Also super important, right? And also early detection of pests and diseases. Here, this can be done with satellite imagery. It can be done with image recognition. For the example we see here, by the way, real field, is detection. And here AI can actually track and detect the trends, right? So we don't need a human to see that. So the AI detects that there is a patch here that starts growing abnormally, all right? And this might be a disease, for instance, okay? Or here we see this was not treated, and it was already spread, right? We see that the yellow areas, which means lower biomass. Now, at this time, the biome of the year, the biomass was not supposed to be to get lower here. Okay, so AI can detect those, or use AI to detect those trends, okay, and give an early warning to the farmer that can go to the field and can apply a treatment, okay. Of course, can be also focused treatment just to this pest or specific disease. And there are also additional technologies that do the scouting. Now, the scouting is not the AI is the identification. Okay, for instance, with drones, okay, when you have you fly drones over the field, okay, and there are cameras that have very high resolution and can even detect tiny pests. Then, all right, they tell you exactly in which point of the field you have pests and which pests, what pest, so you can also target them very specifically. So those are very interesting technologies that are, of course, very useful. Now, regarding pest disease detection and identification, right? So like I mentioned, for instance, the cameras on drones, or in smaller areas can be also with simple devices like a smartphone, right? When we take an image, and now this recognition, this identification is done by AI, like I explained at the beginning, because a human, even sometimes a human eye cannot tell the difference between different diseases, and the AI can tell it better. Can tell you from experience, for instance, in image recognition of diseases, AI technologies are not always, not just the image recognition by itself is not always enough or sufficient, right? So there's we did something like intervention of bots, which is like a virtual agronomist that understands the question, can know what question to make based on the image, and can understand the answers of the farmer, and can actually communicate with the farmer like an agronomist would do. And this is quite amazing. And here you can see examples, right? How this becomes from just an image of a leaf with some kind of a lesion, right? And how the AI can basically disseminate it and understand exactly what's going on there, right? Of course, and by the way, just to mention, before when I talked about the neural network and why it's difficult, why we need AI for this kind of tasks, right? This is an example of very complex data, because when you take an image, all right, you have different lighting conditions, different angles, okay? Even if you have you just want to discriminate between a cat, or to identify a cat or a dog, okay? They both have heads, and they both have ears, noses, basically. So how can you define them? And the image can have different angles. Now imagine pests and diseases, okay? Much more complicated. So we really need a lot of data, and it trains itself and learns. So this is another interesting application. By the way, image recognition is quite common today, okay? Because they are almost predefined, I would say, algorithms for that are readily accessible, and you just have to train them with data and tag the data. Tag the data meaning, all right, saying, all right, this is correct. Yes, this is a late blight. Yes, so you tag it as late blight. So you have the training data, and then you have the actual data that you're using in the AI, in the application itself. Another important or very important application is weather and climate prediction, and there is a distinction here between weather and climate. So in weather prediction, we analyze data again from satellites, from weather stations, from sensors, and can predict short-term weather conditions, again, based on historical data, based on data in real time, and can also give early warnings about extreme weather conditions that are coming, etc. And this helps the farmer, okay? It helps us as farmers, growers, agronomists, okay, to plan our agricultural activities, plan planting time, adjust crop models, and that's for the programs, adjust the irrigation, the harvesting, etc. Climate looks more on the longer terms, because there are shifts even in the season. I'm sure, 100% sure, that many of you are already experienced these kind of shifts, like saying, hey, but we usually harvested in June. Now we have to harvest by the beginning of July or mid-July, or we usually had this pest, now we don't have it, or we have a new pest, a new disease, all kinds of things, millions of examples, right? But there are shifts, okay? Things that we are used to do or practices that we're used to apply are no longer effective. AI helps us in understanding climate shifts and their potential impacts, okay? On the yield, crop development, practices that we have to apply, etc. Talking about weather and climate, okay, there's a very burning subject today, which is the climate change. Okay, some would claim it's not real, we think it is, and actually I think we all experience this. And one of the causes for that, according to most scientists anyways, is carbon. Carbon in the atmosphere. Carbon relates to all kinds of greenhouse gases, right? So there is a very big trend today towards a reduction of carbon footprint, okay? Basically, absorbing more carbon to the soil, like carbon, it's called carbon sequestration, and minimizing carbon emissions, okay? Now, carbon emissions can be all kind of, as I mentioned, greenhouse gases. Now, AI-driven analytics can help farmers adopt sustainable practices that reduce their carbon footprint. For example, optimizing inputs, okay? Using less fertilizers. Okay, now fertilizer and pesticides, they have carbon footprint in the production process, the way they affect the biodiversity in soil, and more. Okay, same with the pesticides, with the fuels, etc. So if we optimize inputs, right, the way we use inputs on the farm, we also reducing carbon emissions. Increasing yield, also this decreases carbon emissions and increases carbon sequestration, because plants, what do plants do? They absorb carbon dioxide from the atmosphere, right? So we have more biomass, we usually have more carbon sequestration. Crop rotation, would ask what's crop rotation related? Crop rotation helps in keeping biodiversity in the soil. More healthy soils, they absorb more and store more carbon. Okay, then again, precision farming, carbon credit management, also another evolving trend. There are companies that basically farmers get paid for the carbon that they save, right, or that they do not emit, all right. So it's becoming an industry, okay, still evolving, but it's something really interesting. And AI is, of course, very involved in that, because it can evaluate trends in soil organic carbon and managing all those carbon markets, etc. This all involves AI. I can tell you that we're working now on a project, very interesting one, of evaluating soil carbon in real time using a different satellite data, basically satellite data, weather models, etc. We have good results yet, not a solution yet, but very promising results for this. Another application is that I mentioned before is the autonomous vehicles and the robotics that do those tasks in the field. So, all right, what we see here, for instance, is a robot that actually sprays. It identifies weeds in the field. You've probably heard of this kind of technology. It goes in the field, it identifies just the weeds and sprays only the weeds. This, of course, saves a lot on or minimizes herbicide use. Very, very effective. And it uses AI. It identifies the weed. It knows where that this specific plant is a weed. Then it can spray it. It knows the rate, all that. It knows where to go in the field, etc. So this technology is heavily based on AI. This, of course, helps reducing labor costs and minimizing expenses. Of course, on the farm is much more sustainable, etc. But there are many tasks that these kind of robots or machineries can perform based on AI, like planting, seeding, harvesting, etc. So very interesting technologies here. Yeah, like we said, like we discussed in precision agriculture, this is more or less the same. But again, robots that can do the harvesting, robots that can analyze the quality, okay, of the harvest of the fruit and can sort it. So AI involved. So things that we had to do just using labor or manually, we now do with machines. Drones, you all know, drones became very popular, also very efficient, of course. But drones by themselves are not AI. They're just a means of collecting data. But where is the AI? And this is not yet really exists, but it might be one of the future development. For sure, many are talking about this. But think about fleets of drones that just do different tasks autonomously, right? There's a disease identified, they go and spray. It's time to spray. It's time to take images. Time to scout. All kinds of tasks that they can perform autonomously. And even there are many, there are so like just stations, right, where they self-charge, so they just change shifts. The drone goes out, all right, it's out of battery, it goes back to its base, all right, it goes back to its base for charging. Another drones continues the task. So this kind of things already exist in other industries, security industry for sure, but it's already also getting to agriculture. Very interesting. There's another application very interesting, like a fleet of bees, robotic bees, like drones that are actually do the pollination. Okay, and so tiny drones that act like bees and do the pollination. Many technologies like that. Obviously, it's all artificial intelligence and based on those kind of technologies, based on data, right? Another interesting topic or application of AI is crop breeding, the ability to analyze vast amount of genetic data, all right, and predicting basically the potential outcomes of different crosses between different varieties, species, whatever, right? Till AI, this was all done manually, trial and error, trying to breed different types of species, waiting for the result, all right, trying again. This is now all, done by AI, or can be done by AI. Of course, it accelerates the breeding process and allows scientists to develop new types of or crops with different resistance, for instance, for pest and diseases, certain pest and diseases, and different traits basically of the variety, different yield levels, different uptake of nitrogen, requirements of nitrogen, etc. But very interesting topic. And the last that I'm going to review today, because before handing it over to Josh, is decision making by AI. And I strongly believe in that. All right. I think this is something that is still a gap. Okay, because we talked about the image recognition, language recognition, autonomous machines, etc. But who takes the decision, right? Can AI really take the decision instead of humans? I believe that yes, all right. But of course, this could be a debate. But for sure, it can take very good decisions. Again, depending on the data that it has, right? Because if we don't have good data, the best AI cannot do anything. Many times when we come to develop a new AI algorithm or something, okay, the first thing the data scientists are asking for is the data, right? And whether there is enough data or whether the data is reliable. You know what? Let me give you an example. Okay, imagine let's take soil sensors. Okay, I have some experience with soil sensors, and now you have soil sensors installed all over the world, and you want to analyze it with AI. How reliable is this? Right? Let's think. The soil sensor just measures just its proximity, all right, a few centimeters. Okay? How many soil sensors do we install in one field, right? There is a limit, all right? It's also costly. But more important or more relevant to this example is what is the weight of this data that's come from the sensor, right? For AI, right? I mean, we have the entire field, I don't know, 50 hectares, 10 hectares, never mind, all right? 100 acres, 50 acres, we install one sensor, all right? How important or what weight does this data that comes from the sensor has in our AI application? This is a question, all right? This is a question, but you can think for yourselves. I think it's statistically, it's not enough. So it really depends on the data that you get. And of course, then you have to cross it with additional data about soil properties and soil moisture and the crop being grown. So something big, it's serious. So decision making, let's talk about decision making. We talked a little bit about the data and the reliability of the data, or even if the data is reliable, all right? How much data do we have, and what's the weight of this specific data in making the decision? So when we talk about decision making, of course, we're talking about data-driven insights. And we can make decisions using AI for resource optimization, like reduce waste, improve efficiency. It can also support sustainable agriculture practices, like we mentioned, with a carbon, right? Minimizing inputs, fertilizers, pesticides, tillage, crop rotation, etc. Improve risk management strategies with all the predictions, forecasts, and of course also bridge knowledge gaps, right? Because today there are actually huge knowledge gaps. And by the way, this is why we have these two ventures. Cropea is more about knowledge dissemination. Yields Up is more about technology. And yeah, so this is how we do this. One is large data set, multiple data sources. We can't rely just on one data source for making decisions, right? So about anything, not about fertilizers, water, pesticides, any activity in the field, we need multiple data sources, and very important also historical data. We have historical data, right? We can train the algorithms more quickly. okay, to learn, to adapt, and actually to make better and better decisions time after time. Okay, I will pause here. Josh, are you with us?
I
See,
am here. I'm here, loud and clear. I just need you to stop your video so I can start my video and share my screen, and I'm
all
good to
right.
go.
Okay, so I'll stop my screen sharing and let Josh continue with we'll show you actually AI system in work. Josh, we can't see you yet.
Yeah, you have to allow that. You have to stop your video, perhaps.
All right, let's try it on.
And I know you have to enable me to share my screen. No worries.
You can share a screen, Josh.
Thank you. Let's see if you can see me. You cannot start your video because it has stopped. Okay. Just a second. You guys can't see me. Can you see my screen in a second? I just want you guys to see me because that's not really fair. It's not allowing me.
I'll make you the host, Josh. So
yeah, do that. Do that because it's you know, it could be a recording. No one would believe it's actually me.
you're the host now.
Beautiful. Let me see if I can have the permission to start my video. And I'm a real person. Thank you guys all thank you, Guy, for that presentation. It was great. I hope everybody here found it very informative. Now I'm gonna be able to, I have the pleasure to showing you a little bit about our technology Yields app. But before I actually get into it, I pulled up a screen right here and some other additional barriers and constraints. So essentially in this realm of agriculture, the problem of fractured data, which you can see here, plagues farmers. So there's numerous agricultural tools available, each excelling in a specific task, but failing to consider, some other crucial aspects in the actual decision making. For instance, there are some companies that say they provide fertilizer recommendations, but essentially they only provide or focus on the nitrogen recommendations. This total disregard of the other essential nutrients necessary for a healthy and productive crop. So these fragmented data and the lack of cohesive insight make it extremely challenging to the farmer to integrate them into an actual practical and actionable farm strategy, which you can see right here, the confused farmer. But to add to that, the guy was also talking about the other tools involved with artificial intelligence, okay, and the great things about artificial intelligence. However, there are significant barriers that hinder the widespread adoption of AI technology in this specific sector. With, of course, cost being the primary concern. All right. For instance, you have sensors you can see on the screen. They do have the ability to collect valuable field data, but their coverage is limited to a relatively small area. You see right there. And on top of that, each sensor comes with a hefty price tag, making it impractical and unaffordable for the majority of the farmers. Not all farmers, but the majority of farmers. This cost constraints applies not only to sensors, but also extends to fertigation machines, satellite imagery, weather stations, making it challenging for farmers to integrate these technologies into their operations. As a result, the high costs associated with AI technology in agriculture acts as a major obstacle. So it prevents a lot of farms from harnessing the benefits of these advanced tools. So now you know why we developed Yields app. We developed Yields app to bridge the gap between data, knowledge, and practical implementation in agriculture. Our goal was to create a remarkable example of strong AI that doesn't restrict adoption due to technical limitations and the lack of data collecting tools. We are a game changer, taking the industry to new heights beyond new constraints, of the traditional weak AI applications. With our system, with our technology, there are no barriers to its usability. It seamlessly integrates data, it seamlessly integrates the knowledge and the practice, making it exceptionally powerful for farmers to harness the full potential of strong AI. Even in the face of this limited, even in the face of limited data collection tools. You don't need to have the drones, you don't need to have the sensors to actually harness the power of AI. I'm going to show you how. So data sources, we saw a little bit before of all the different data sources and the fractured data, I would say, okay? And this is where Yields app steps in to revolutionize the agricultural decision making. So our technology addresses the issues of fractured data and unifies it and unifies the agricultural insights, providing the farmers a actual comprehensive solution, okay? I'll give you an example, for example, how Yields app actually solved this problem. Let's consider a scenario where a farmer wants to optimize their fertilizer applications for a specific crop. So with our system, Yields app, the farmer can input various data points such as soil quality, crop type, weather conditions, and nutrient requirements, unlike the other tools that only focus on one aspect. So we like to take a holistic approach and consider all the essential nutrient needs for the crop's well-being, as well as the weather conditions, as well as the historical actions or previous data that we had in the field. So what I wanted to do is to give you a little bit more visual aspect of how it's actually working. Now, I mentioned you don't need to have a satellite. You don't need to have a sensor, soil, tissue plant sensors. You don't need to have this information. What you need to start running the AI engines in our system are the simple location. Well, a farm would be a good start. So a farm, location, the crop type, the yield target, planting date, and if you have previous crop, the previous crop. This will enable the engines. Why? Because automatically Yield app provides the nutrient data. We provide crop models, pest and disease models, weather models, vegetation indices. We even provide you the regulations and compliance standards from your region. Now, again, these are the enablers. This is how you can start using the system today without any of those technologies that Guy discussed in the previous slides. The optional data, okay, this is where if you do have those fun toys like the drones and the sensors, you can add the additional layers. You can also input soil analysis, tissue analysis, water analysis, all right? You can add another layer of regulations and requirements. So you may have a regional compliance and regulations, but for the company internally, you may have another layer of standards and requirements which you can add and adopt into the engine. Okay. Also, specific genetics. I think Guy touched about that. With all these new genetics, with all these different seeds, you know, they're all going to play a very important role. Some will be more resistant to specific pests, some weather conditions. So those are some optional data that you can add. All right. Again, sorry about that. A little jump the thing. So then you have the expanding horizon. So this is taking more information. All right. And this is specifically for, a Guy mentioned, if you have historical crop data, records, yield records, specific scouting occurrences, weather data. So all these can be optimized to give better prediction, all right? And what happens? You get a dynamic protocol. So this is provided to the farmer, to the companies, whoever's utilizing the platform itself. Now we see what an actual dynamic protocol is. Okay, so what is a dynamic protocol? So our system will provide farmers, for instance, fertilizer protocols. Okay, the fertilizer type, what type of fertilizer to use, when to use it, how much to apply. Okay, maybe additional protocols to that. It also, the system will optimize. So it's going to find the most efficient, not only by the chemical needs, all right, organic or regular, it can also define it based on the nutrient composition. So what's going to be the best option for that? All right. Additional, we have soil health protocols. So the system is always going to balance your soil fertility. That's its goal. It's during the season, as it progresses, it may make adjustments due to, guys said, weather conditions. Okay, nutrient deficiencies, additions. All right, so it will provide you soil amendments to improve the soil. It will give you suggestions in regards to crop rotation, cover crops. Okay, then we jump over. We have scouting protocols. So we have the pest and disease risk. We have specific thresholds. We have the identification of location. We also have alerts in the system when they trigger these specific models and thresholds to when to scout and what to look for. Teaching your field, learning your field. Okay. Last but not least, we save the best. There's crop protection protocol. So preventative and reaction treatments. Okay. Products to apply, the active ingredients, the modes of actions, the application rates. All right. The spray time, when to spray it. All right. In addition, especially when you deal with the pesticides aspect, the safety, regulations, and compliance. All those are pre-programmed, predefined into the system. So now that we had, a little look at what delivered, let's go actually see it live through the farmer's eyes. So bear with me. I'm just going to do a transition to jump into the farmer's account right now. So if it doesn't work on my first shot, like it didn't, it's still there. Fantastic. All right. I just want to see. Guy, can you see the screen? I just want to make sure I didn't turn anything off.
Yeah.
Beautiful. Thank you so much. Okay, well, we're going to look now through the eyes of the farmer. Now, please apologize. I have a big screen so I can see all the little details right now, and I'll be reading out the screen. So what we see here is the specific field. Okay, I can also open up my tab and I have field options. So overview, treatment, scouting, field tests, fertilizer plans. All right. In the management section, I can manage my different nozzles, my different sprayers I have. All right. I can manage specific pesticides, fertilizers. I can add my additional sustainability card. If I want to go organic, I could define that as well. All right. I'm talking a little bit fast because there is a lot and we'll go step by step. So what we see here is the field overview. All right. We can see there is a current issue. Okay. So this is an active live field that's going on right now. I picked this one out because we actually have a dynamic action that's happening. So what we see is the next treatment is planned. So we do see fall armyworm. There is an infestation in the field. We do have a next treatment that's planned. We have the product, the application rate. We have the weather. And we also have notifications. Now, notifications, it will identify you. So if there's any alerts, okay, nutrient deficiency, pest and disease alerts, weather alerts, weather conditions, update to fertilizer recommendations, all these will be notifications. In addition, the advisors that may be the consultants that are working on this specific farmer's account can also leave their own notes, allowing the farmer, hey, go into the field. I want you to check for this specific, or I want you to make my application here. So it's a notification. This is just specifically for this field. As we scroll down, we can see pending activities for this field. We also see a nice little image of the field itself. I will scroll in, not too much. All right. I won't get into in this specific demonstrations, but we do have lots of demonstrations that go in depth. Some with more agronomic, some more with the satellite models that we utilize. Okay. So here I just show you, we do have satellite indices. All right. Just to give you a little perspective. And again, I won't go into detail with the different models, but we have different models for different crops, for different uses for that. Okay. So here's our NDVI. As we scroll down, we see the pattern, historical pattern right now, or any infestations. So we can see here that it's been a pretty good year. And then we had a little infestation, fall armyworms notified. Treatment was applied. Last time they went to the field, there was no found. All right. But lately there's been a new outbreak. Okay. So we notified that we already have a treatment. We see the outbreak. We already have a treatment planned and it's planned for tomorrow. Fantastic. So we'll get those buggers. All right. Now we scroll down, we have the full out calendar. So all the actions has been taken on the field. So from treatments, applications to scouting, everything that's been done on the field is going to be here. All right. So I'll go historical, for instance. If I go back in the beginning, I can see right here, for instance, we have treatments. Okay. And I can see this is the beginning of seed. This one, they use a treatment for herbicides, right? And we saw throughout the year, we didn't have any weed breakouts. So that's fantastic. All right, we have our forecast on the right-hand side, okay? But this is where I really want to get to because we are running out of time, all right? This is our crop information, all right? This is real time. This is what's going on. These growth stages are accumulated by growing degree days, so we have accurate growth stage, okay? And we can also make adjustments if you're on the field, if you need be, but these are automatic. So what we see here is our planting date. We have our target, our target potential that we're trying to achieve, the current growth stage, and then on the right-hand side, we have a graph. This graph is very cool because what we see is, first of all, I'll take off the green. This is 5 to 10 years of historical weather data gathered by growing degree days, which you see here, GDD, growing degree days, so the heat accumulation. Okay, and when I add the GDD, the green one, which is a green GDD, this is the current one. This is what's happening this season. Now we can see that it's been abnormally warmer than the previous seasons. We see that clear as day. We can also kind of correlate what else is going on the farm on a different level. Now, we're not there. We're sitting here for the field. Well, I could look at the precipitation. Now, this is not an irrigated field. They need to hope for the rain, okay? Now, I can see right now there could be some causes for water stress in this crop. All right, and the water stress, for instance, well, because at this specific stage, you would need approximately over 700 millimeters of things. So, and it hasn't achieved that. All right. Once the farmer has verified there has been water stresses. Now the system, and it's already the fertilizer class, but we'll jump into it, has actually made adjustments to the fertilizer recommendations. So what I'm going to do is I'm going to show you guys how quick or how essentially how quick it is to build a fertilizer recommendations for adjustments. So if I go here to the fertilizer section, oh, I just got kicked out. I don't know why. Apologize for that. So what happens, you just leave it running without touching it. Okay, guys, 1 second. All right. Well, right now, it's actually really cool that you guys are looking at this. You can see in the top farmers, consultants, company, organizations. So the platform does come in many forms. Today, we're kind of just looking at it from the farmer view because that's also the critical, right? The production side of that. All right. And they have the ability for consultants to access their farmers, etc., so on. So you got to see a little bit more. Wasn't part of the plan, but we're going to jump into it. All right. It's going to jump back into my field. It's got Blue Hill. All right. So that's my farm. Beautiful. Oh, I'm not going to go Blue Hill. I wanted to go to Briggs. Briggs. Sorry about that. All right, so I'll just jump right now into the field where we guys last left off. Okay, and then like I said, I want to go create a fertilizer plan. Well, this one already has a fertilizer plan, so we're actually going to take a look at it. Okay. Now, details. So these are automatically generated fertilizer plans. So once you set up your account, once you've selected your crop, you'll have the option to select your crop variety. Now, I said that's very critical because each crop variety has specific nutrient needs, fertility, or applications. Again, can be more resilient to specific pests and disease. All right, so these are already predefined internally. So by selecting that variety, you've already created your nutrient map. Now you can see here, this is our fertilizer applications that have been applied. Now, there was an application, okay, previous one that they made the adjustments because this is a live field. I wish I could show it to you. But we had 84 kilograms that was planned to be applied. During the system actually requested our farmer, to make an adjustment due to the drought conditions. Farmer generated a recommendation. There was an alert that allowed them to generate a recommendation, and it adjusted it saying no, not to apply the urea that was anticipated. And the reason was nitrogen was a restricting element. It was not going to help the plant by providing more in those specific conditions. So those are the fertilizer plans. You can see here, you have the ability to add on specific soil and tissue and water analysis in order to calibrate, to give you the recommendations. All right, another layer. So that, okay. We have the fertilizers where you can dedicate which fertilizers are in stock or non-stock. You have the specific nutrient targets. So you can see the nutrients that you actually need to achieve, and that based on that, see the fertilizers that are helping you obtain that. Okay. You have the full flexibility also to have full adjustments manually if need be. Okay, so that's the fertilizer plants. Very cool, very easy to use. Let's take a look before we jump into the scouting and the treatments, the actual field tests where they can be uploaded. You can upload it through a CBS file. Okay, you can also just enter manually. So I'll give you an example where you have the test. We'll just do a quick one right now. New test. You'll just put in the date that was tested. You'll select the zone that it attributes to. You could put in this sampling depth. Okay, and this is all from the report if you're holding it in hand. If you have a CSV in multiple fields, we can just upload it into the system. You can, essentially. You'll select the soil conditions, you'll put in the bulk density. Now here you'll notice we have something called laboratories. Very cool feature, okay? Now, every laboratory has its own extraction methods. Even all countries may have a different threshold or another parameter, an additional parameter. For instance, Hungary has an additional parameter down here with Ka rating, okay? And also different soil textures as well, okay? So you can see they have different categories as well. So they are different. We do have the flexibility, and this is the beautiful thing about our system. is that we can predefine it. So you essentially tell us which laboratory it is. Once you've selected the laboratory, it already predefines its specific requirements, thresholds, and extraction methods. Okay, we'll see here we'll put in our information just to show you quickly how we can create or enter our soil information. You go next, continue, right here. There we go. And we'll see here, you can see the different extraction methods. All right, we're on the default, so we have the access to do whatever extraction methods we've done. All right, we'll put in, you can put our numbers. Right now, I'm just flowing with it. Okay, once you put in the data, you'll save and close. And like I said before, you can go into the fertilizer plan. You can add it into your plan. Okay, select the soil test, add it to a plan, or you can also add a soil analysis, a tissue analysis, and it can recalibrate your plan as well. Okay, so we saw a little bit now about the fertilizer plans. Okay, very important. We saw the field test. Okay, so now we're going to look at another aspect, which is the treatments. And then we'll get to the things. So these are, we can see our historical treatments, which have been applied, which have not been applied. I can see right here, the one that we saw in the overview is not been applied yet. Okay, so when the farmer does make that application, they can go in and mark it as applied. Understanding what products are being used, this is very important, so it doesn't, the pest or doesn't create immunity overloading with the same active ingredient. Okay, and recommended treatments. So in the recommended treatments, you have ones that I can recommend based from the consultants. Consultant can come in and provide their recommendation, but the majority of the time you will have automatic recommendations. Okay, when an issue happens in the field, the system is going to react and it's going to give you a notification, and it will give you either a recommendation or a suggestion to go to the field to check specific issues. I want to show you that live. I'm going to trigger something, so I want to see what happens. How do we trigger the system? Well, I can't control the weather, because if I can control the weather, I'd show you guys how we can do that. But what I can control is information from the field. Okay, so a tissue analysis, that would adjust the program. Okay, if I go to the field and see a pest or a disease, that can trigger the program. Okay, so what I'm going to do is I'm actually going to trigger the program. I'm going to go to the field right now. I'm going to say there's an issue in the field. Okay, and by doing that, I go add new. Select the zone. Okay, you can have multiple zones, the fields with different crops, issue types. Okay, so we can just go to the field. This could be a pest, a disease, a no findings, or a general observation. Okay, the thing is, you need the system to also learn. All right, because once you've locked that field in, it's going to be consistently learning, nonstop. All right, so we need to know the actions that have been taken. So here we go. We have, and apologies for the so. There's a lot of so's. We have, let's say, we'll do a pest. We'll do a armyworm. Because no, we'll do something else different. We'll do a corn leaf out. Yeah. Okay, I want to change it up a little bit. I just want to let them know that there's I've seen some leaf aphids out there in the field. Okay. Actually, we have a pest. It won't look nice. Let's do a disease. It'll make it look beautiful. So I'll just select it. Just to note, all the pests and the diseases you see are specifically for this crop. So that means whenever you see a list of this, you'll have that option. All right. So we have corn, gray leaf spot. All right. I won't go into it. I said there's a lot of things we can go into. We're in simple mode right now. And that simple means we're just going to tell very simply what's happened. Okay. So we'll put the severity. Okay. We'll do low severity. Let's see. And we can do infestation rate. Okay. So let's say a small percentage. We just saw a little outbreak in there. Okay. I can upload photos. And we can see that we can manage that. So we can see that that's perfect. All right, beautiful. And then I'm going to, this is the identification. So I think Guy mentioned it before. You saw it in the previous one. All right, so you have that option. So I'm going to save this, just put in the date because that's a requirement. Okay, so what I want to do is I'm going to jump to the overview. That's going to be a very important thing. All right. And right here, okay, so I can see that there is a new treatment that's been applied that needs to be applied. I can see that there is a new issue right now. All right, so you can see here, new pending activity is recommended. All right, and so the system has automatically triggered a new treatment based on that specific. Or you can see here, there's a new one to be applied today. Okay, or I can make, if I want to change it, I can make adjustments as you see fit. So I wanted to give you guys a little field overview. I'm going to jump back in. I want to show you a couple of case studies, give you a little more of how the dynamic protocols actually helped farmers in the field. So I'm going to jump in. Here we go. There we go. Okay, so some of our case studies. And I can jump in. I can not have to look at the big screen anymore. We're good. So these are some case studies that we've done with a variety of different crops, just to give you guys a feel of some dynamic protocols that's happened in the field. These are real time. One of them is in corn in southern Mexico. There was a end split. So essentially, the farmers got a recommendation, a generic recommendations from their fertilizer dealers. Okay, they recommended to do a application, 2-split application. When we ran the information through our system, the system actually recommended to do a 3-split application. This is what happened. So other than seeing a nice, pretty field on the vegetation from the NDVI, what actually happened is a yield increase. So right there, night and day, you have a 17% yield increase by splitting. There was no change in the cost of the fertilizers. All right. Another demonstration is building soil and health and fertility. This was a 3-year project. And during that, it was building the fertility, creating high field uniformity. So this is what was achieved. You can see the visual, you can see the picture right now of it. All right, the 3-year trial, in-season nutrient, it did the crop rotation for the farmer and helped the farmer build up its soil health. There was a 38% increase in this field specifically throughout the years. All right, weather effect. We talked about it a little bit in the demonstration. So it can actually, the weather can affect the system and the program that's on. All right. So if it needs to make adjustments, like in this field, which was in Oman, it was corrected the deficiencies by recommending in-season fertilizer application. All right. We have Hungary. This is a large scale. We had over 100 farmers using this, using our technology. And roughly it was between 15 to 26% seen an increase. And another addition, they used 22% less pesticides, a major aspect. We also look with other crops. So orchards, vegetables, over 270 different crops that you can see from the case studies themselves, the direct results correlating to that. All right. Also with our prediction, that learning engine is very good. So I'd like to end our slide right now. The end didn't pop up, but I'll stop my share. And this is the perfect time for us to have Q&A. We do have a couple of questions right there. So I hope that I'm going to let Guy jump in as well. Can you unmute, Guy?
Yes, but allow me to
Yep,
share my video.
already there. Thank you, guys. I'm going to have to take my video off.
All right. Oh, for sure, there is a way, a technology to share both our videos.
I thought it would.
About that.
I thought there would be. You know,
no, there is. I just don't want to waste everybody else's time here. So we'll just, I'll jump in. Thank you, Josh, for the demonstration, the comprehensive demonstration of Yields Up. Let me just answer some of the questions we had here. And again, if you have more questions, feel free to ask now. You can ask them through the chat or the Q&A. So there's a question here about how can we analyze data from field and forecast different variables using a software of AI where different data will be put to predict yield and other variables. Okay, I'm trying to understand. But if I understand correctly, if the question here is about how different variables can be input into a platform or into the platform. So I think Josh answered that. A lot of the data is automatic data collected like satellite and comes with a satellite weather, etc. And there's also like a manual input that can or importing data, and of course it can be connected to different devices if there are any on the on the farm, right? And based on that, of course, as we saw also the crop development, it can predict a harvest, yield, etc., depending on the crop. Yield prediction for all crops is not always possible. I see that Weissman also has a question. Please just ask your question through the chat or through the Q&A, right? Because you raised your hand. Regarding scaring birds in rice fields, I reply that privately, I'm not aware of such technology. I assume there might be such a technology. Very interesting question. How can a application of AI in agriculture, and this is a question about Africa, okay, impact Africa, where conventional practices are still in use, and the application of technology in agriculture is poor. So that's exactly, all right, where AI can really help, okay? Because yes, of course, when there is a lot of other technology and when data collection is easier and we have all the devices, then sure, it's easier. But when we collect data for AI, and when we have AI systems, we can actually apply those insights in other places, right? On other crops, in other places, depending on the exact situation. But I can tell you that first we're working in Africa a lot, and the information collected, you use the data that is available. You use soil maps, using satellite data, using weather forecasts, and so all that is a first layer of data that can be used and can be helpful in actually in significantly improving crop performance in yield. So although the data is, yes, there is less data, that's for sure, but it's with what we have, it's already very powerful to improve or to increase crop yields and performances. Another question, can manually collected data be interpreted and used by AI? And I think Josh just showed that. So some of the data, like scouting in the field, is manual data, right? And that's important data for AI. So of course you need a large amount, but as I mentioned, we not only us, also other companies, they have a lot of data already in their systems that enables like extrapolating this, and actually you get the benefit. You get a benefit from that. So manually added data can be used. Of course, first you need to have a lot of such a data, of course. Vikas, also please make your question on the through the Q&A section, right? And I'll be happy to answer. Regarding coconut plantations, there's a question here. Yes, so basically Yields Up also supports coconut and other crops. There are some other questions here. Or that's a good one. All right, yes, it says there are many farmers that were, companies that use they already have systems in place, like ERP systems and other software. Can your technology be integrated with such systems? So basically, yes, of course, it depends also on the other side, but the way this was constructed and created is that everything is built with APIs, which can actually, this is what allows, right, to connect to practically any other system, okay, whether it's a device, whether it's another software, and etc. So this goes especially with large companies that already have some technologies, so they are getting from us not the UI, right? So sometimes they don't use our user interface, but APIs that can connect to their systems. Okay, I'm reading this question about blueberries in Chile. Increase.
Yeah, it is possible. I've already read it. It's about introducing it internally with a flight time delays forecast. We've also worked with other companies that do specifically logistics, so we can basically, like Guy said, integrate this with the APIs.
Yeah.
Sorry, I have no video.
Yeah. Can it work with broccoli, onions, wheat, soybeans? Of course, we saw examples. Actually, we didn't, but with yeah, soybeans for sure, wheat, of course, onions, broccoli. Yes, we have
Just to
working.
add on to that, it's also open field. It's containers, it's greenhouses, it's plastic greenhouses. Okay, so essentially everything. Now, again, you're not going to get really good use from the NDVI indices with greenhouses. We understand that. But again, with a lot, we were able to define and work with all different kinds of operations.
Yeah. Yeah, we have it in hydroponics, the greenhouses, open fields, and the variety of crops. There is also a question about, can such technology work for disease detection or prediction in the field? Of course, yes, we showed that. This is one of the main features here, and very important, because it's creating the protocols, the dynamic protocols. So you get a protocol at the beginning of the season based on your history, based on the history in the region, based on a lot of data, analytics, and models, and of course throughout the season. Yes, Josh.
Yeah, I would like to jump in because one of the aspects too is it touches base on the previous one about if they don't have any historical data. Okay, so one of the things is those manual scouting and things. This is going to be very critical. Okay.
Yeah, definitely. Right. What else we have here? Okay, I see that because your hand is still raised, so please make your questions through the Q&A. Sorry, there's another.
And I think that was the neuron talking about teaching your field, because the system, for instance, will be triggered by specific pest and disease thresholds in the system that are having our models. So if there's specific weather conditions, climate, it's going to identify and say, okay, there'll be a risk of a specific pest or disease. And then you're teaching it as well. So you go in the field to say, hey, I do see it, or there's no present. Next season, you're not going to have it based on those same requirements. It's already self-taught itself. Okay, so that when you do get a next season alert, it's going to be a lot more accurate. Go to the field, hey, there is an issue.
Yeah, and another question here: can we monitor insect dynamics? So as Josh demonstrated, right, you can even see it visually, right? So you can monitor the dynamics of insects and diseases, right? Some diseases are detected automatically in open fields, and some and the dynamics are recorded. Of course, the platform records insect dynamics, treatments that were done. It considers active ingredients. It considers the regulations. It considers everything, basically. All right, that is the equipment to apply, and the insect dynamics is, of course, very important. Threshold, specific threshold, biofixes, and more. There's a lot more.
Phenological stages with the growing degrees, we utilize all the aspects we can.
Let's see what else.
Josh presented. I can answer. Josh presented yields app. How much does it cost? That would be all right. So what we do is we work based on the field size. Okay, and we have a price per field depending on the field size. We basically have personal demonstrations discuss about that. But again, it is affordable to all farmers. This is what one of the main things is that we make it affordable to everybody with technology, or they don't have the means of those fun toys, let's say drones or sensors. Okay, we do work a lot in Asia, in Africa, predominantly small farms as well. But again, a lot of times what we do is we work with larger organizations as well. They provide the systems to their farmers. Okay, and they can manage it from a scale. Now, we never talked about the other aspects of the platform, but again, we showed you from the ground up, right? What the system is going to do on the productive side to improve the farming, and then we have additional layers for traceability for food and beverage companies, banks. We work a lot with the banks as well. Just to give you a little note.
Yeah, a question here about organic farming. Okay, because we didn't talk about this. You see, there is a question: can yields be used in organic and sustainable farming practices? So actually, we touched that a little bit with the sustainability settings and configuration. Of course, there are different modes. There is a mode for integrated pest management, for instance. There is a mode for organic, completely organic farming, and basically it can be adjusted to any certification. Okay, so into any mode of a farming, made it very flexible in this, and that's actually it must be practical. Okay, if you have a technology that is not practical, all right, this does not adapt and suit the different practices, then it will not be used. Right. So that's very practical here. Let me see. I don't see any additional questions. All right. So I would like to thank you all for participating in this webinar. I hope you enjoyed. I hope it opened your eyes a little bit about AI applications in agriculture. I can tell you I'm very excited about the future of AI in agriculture in general, but specifically, of course, in um, in agriculture. And again, I promise again to send you more updates, information about this technology and others this time. So thank you very much for participating, and yeah, maybe see you in the next webinar that we'll have. Thank you. Bye-bye. Bye, everybody. Thank you very much.
And what I'll do is I will also reach out to people sending email if they want to get in touch. So I'll send you guys all a thank you. So you guys will have our personal emails. Again, if you have any questions, please feel free. Thank you again for joining, and we will see you next time. Thank you.
Bye.